This tiny needle explodes with the force of 1 billion nuclear bombs, defying the laws of physics. This phenomenon is made possible by the precise manipulation of heat and pressure. When a needle is heated to extremely high temperatures, it begins to undergo a series of rapid transformations. The atoms within the metal start vibrating wildly, causing the crystal structure to break down. Imagine a grain of sand containing an entire library of information, where each particle is intricately connected. But that's not the strangest part. The needle can be restored to its original shape and structure. This process is known as superplasticity, and it's a fascinating area of research in materials science. It's like a magic trick, where the needle appears to change its properties and behavior. But what's happening at the molecular level to make this possible? Scientists have discovered that the needle's structure is composed of tiny defects and imperfections. These defects act as seeds for the superplastic transformation, allowing the metal to flow like a liquid. It's a remarkable example of how small-scale changes can have a profound impact on the macroscopic world. But wait, until you hear what comes next. The implications of this discovery are far-reaching and profound. Imagine being able to create materials with unprecedented strength and durability. This could revolutionize industries such as aerospace, automotive, and construction. The potential applications are endless, and researchers are eager to explore this new frontier. However, there are also concerns about the environmental impact of such materials. Will we be able to produce them sustainably, or will they contribute to the growing problem of waste? These are just a few of the questions that scientists are grappling with as they continue to study this phenomenon. And then something unexpected happened. A team of researchers discovered a way to create superplastic materials at room temperature. This breakthrough has opened up new possibilities for the development of advanced materials. The process involves the use of a specialized technique called mechanical alloying. This involves subjecting the metal to intense mechanical stress, causing it to undergo a transformation. The resulting material has properties that are unlike anything seen before. It's as if the metal has been rewritten at the molecular level, giving it new and exciting properties. But what about the potential risks and challenges associated with this technology? Researchers are working to address these concerns and ensure that the benefits of superplastic materials are realized. The future of materials science is looking brighter than ever, thanks to this remarkable discovery. And it's not just about the materials themselves, it's about the possibilities they open up for us. Imagine being able to create structures and devices that are stronger, lighter, and more efficient.
This is the promise of superplastic materials, and it's an exciting time to be alive.
Subscribe for more incredible stories like this, and join our journey of discovery. Like and comment below to let us know what you think. Are you excited about the potential of superplastic materials? And don't forget to hit the notification bell to stay up to date with the latest videos and updates. Thanks for watching. We'll see you in the next video.